Good morning, friend. Today we will see the simulation of the CMOS in the Microwind software. We know CMOS is the complementary MOSFET. CMOS is a combination of P-type MOSFET and N-type MOSFET. So this is the circuit diagram of the CMOS. This is the PMOS and this is the NMOS. The gate terminal of both PMOS and NMOS is connected and we apply input and we observe output at the drain terminal of the PMOS and the NMOS. VDD is connected to the source of the PMOS and ground is connected to the source of the NMOS. We know threshold voltage of PMOS is less than 0 and threshold voltage of NMOS is greater than 0. Means when we apply, when the input signal is low, then when input signal is low, then PMOS is on and NMOS is off. And when the input signal is high, then NMOS is on and PMOS is off. So case 1, when the input signal is low, then PMOS is on because threshold voltage of the PMOS is less than 0 and NMOS is off. So this is the equivalent circuit diagram of the CMOS when we apply input signal low. Then see PMOS is on, so we replace PMOS by the short circuit, and NMOS is off, so replace NMOS by the open circuit. So see, output is directly connected to the VDG and capacitor. This is called parasitic capacitance present at the output terminal is charged through the VDD. So when the input is low, then output is high. Means it acts as an inverter. When the input is low, output is high. Again, when the case 2, when the input is high, then PMOS is off, so we replace it by the open circuit, and NMOS is on, so it replaced by the closed circuit. Now output is directly connected to the ground, so if any charge present on the capacitor, it will be discharged through this ground, this path. So when the input is high, output is low. So in this way it acts as a inverter. So when the input is low, output is high, and when the input is high, output is low. So in this way it acts as an inverter. Now we have to design the layout of the CMOS. Okay, so this is the layout of the CMOS. So in CMOS we have to design both PMOS and NMOS. So upper this is the PMOS and below this is the NMOS. We know the how to fabricate PMOS and NMOS. So for the PMOS, the substrate is N type. So here we take N well. This is the N well. N well. So in N well we have to design P type MOSFET. So for P type MOSFET we require P plus diffusion material. So this is the P plus diffusion material. Size of the P plus diffusion material is 4 by 14 lambda. Means minimum width is 4 and minimum length is 14 lambda. So in this the PMOS, the upper terminal, this is acts as a source, below this acts as a drain, and this uh, the acts as a gate terminal. Now for the NMOS we require active material is N type. So this is the N type active material. Size is same, 4 by 14 lambda. So this terminal acts as a drain of the NMOS, and this terminal acts as a source of the NMOS. So we connect ground to the source of the NMOS and VDD to the source of the PMOS. Now we connect both gate terminal of PMOS and NMOS by the polysilicon, and we here apply input and drain of the both PMOS and NMOS by the metal, and we observe output. The minimum width of the polysilicon is 2 lambda, and height of the polysilicon, this is the height of the polysilicon above the active material is 3 lambda. Now we have to design this in the Microwind software. So this is the Microwind software, This is the 5 lambda scale. We have to make it as a 1 lambda scale. So just click view, zoom in and just click. Now it becomes 1 lambda. Now click on this, it becomes 1 lambda. Now we have to design both PMOS and NMOS. So first of all we have to design PMOS. So we have to take P plus diffusion material. What is the size of P plus diffusion? 4 by 14 lambda. 4 by 14 lambda, right? This is the P plus. Now we have to design Nmos. So active material is N plus diffusion. So this is the N plus diffusion. What is the separation between PMOS and Nmos? It is 12 lambda. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So okay, now we have to just change. This is the, just we have to add 4 more. So it becomes 4 by, and separation between this is 1 to 12 lambda. Okay, now we have to create contact for the PMOS and NMOS. So this is PMOS, so we require P plus contact. This is the P plus contact. Just click on this. This is becomes source. This becomes, now again for the N type NMOS. So this becomes N, and that's drain of the NMOS. This becomes source of the. Now we have to create gate terminal of both PMOS and NMOS. For gate terminal we require polysilicon. So this is the polysilicon. Height of the polysilicon above the active material is 3 lambda, right? We have to check design error step by step. So if we click on this, it shows no error. Now again we have to create gate terminal for the NMOS. Okay, so this is the gate polysilicon. Again polysilicon must be in middle between the source and the drain terminal. Just click on DRC error, it shows no error. Now we have to connect both gate material, both gate terminal by the polysilicon. So this is a polysilicon, just we have to connect both. Very simple, just we connect both. Now we have to connect drain of the both NMOS and PMOS by the metal. Now we have to connect the VDD. So just we take metal strip at the source of the PMOS, and again metal strip. Now we have to just connect. This is the ground, so we connect ground. Just we have to make it in center. So just delete this. Take, delete it. Just we have to delete it. Okay, just wait one minute. Just we have to take ground. So just click on this and just take ground. And again we have to VDD. So just take VDD. Okay, now we have to just make N-well, right? We have to make N-well. So N-well, this is the N-well. So just take separation between the active material and N-well is 6 lambda. So we will move diagonally. So this is, we will move diagonally. So this is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So we take this, again we take 1, 2, 3,